Okay, we're going to go ahead and start with this situation about ride tickets at the carnival. I'm going to start with a table that if I have 0 tickets, then I've spent $0. If I buy 1 ticket, that would be $2 because they're each $2. 2 tickets would be 4. 3 tickets would be 6. Go ahead and fill in your table with me. All right. And we have a graph, so we can go ahead and graph these as well. So you can pause the video to graph and then jump back in with me. So after you've plotted your points, you have this question right underneath your graph that says, should you connect the points? Why or why not? So this is something we've talked about, connecting points or not connecting points. In this case, connecting the points would mean that I could buy partial tickets. So it's always based on the independent variable. If the independent variable has fractions or decimals or partial things, then it's fine, but otherwise, if the independent variable is whole numbers, then no, you can't, because we're not going to buy partial tickets and spend half of our money. Then if you go over to the left of the table, it starts asking you these questions. Which quantity is independent? Well, the independent would be the ride tickets. Which quantity is dependent? The dependent is the total that you spent, the total money. And you can find that information from the table. You know, this is always your X and this is always your Y. You can find that information on the graph because the independent and dependent variables are labeled on the graph. And you can just think about the situation, that the money depends on how many tickets you buy. The next question, what values for number of tickets would make sense for this scenario? Well, I could buy 0 tickets, 1 ticket, 2 tickets, so on and so forth. It wouldn't make sense to buy negative tickets, and it wouldn't make sense to buy 1.5 tickets. So these whole numbers are kind of what I expect. For a total amount spent, 0, $2, $4, these even numbers because of each one being $2. But again, I'm not going to spend $3 because that would be a partial ticket, and I'm not going to spend negative money because we can't do that. So the number of tickets describes the X value of the situation, and the total amount spent describes the Y value of the situation. And then you have a couple little things on your handout. This X value is also called the domain of the situation. I think you've heard this word before. And the Y value is also called the range of the situation. So you have those extra blanks to fill in on your notes. And then this is kind of why it's important. It goes back to the dots versus a line, and I told you that there were vocabulary words we hadn't gotten to yet. Well, we're here now. So this is called discrete data, and you have all these blue words to fill in. And discrete data just means that the values are distinct, so they are unconnected. It's things that are counted. We're counting tickets. I can buy 1 ticket, 2 tickets, 3 tickets. In a graph, they're separate, distinct points, and they're plotted, and only these points have meaning to the problem. The things between it do not have meaning to the problem. So we've talked about this before, you just have never heard it called discrete. So that's the only new thing going on. So make sure you have all these words filled in before you continue. So now, because it's discrete, we're going to be writing the domain and range. There's certain ways that you write it, just like there's certain ways you write equations and those kinds of things. So it says, since the independent variable is the domain and the dependent is the range, let's take a further look. So our domain, that means all the possible X values. That's what we just stated a couple slides ago. The domain is the X values. So there's 2 ways that we're going to write it today. We say that the X values are in the set that contains 0, 1, 2, and then we put this ... because it's going to continue in this pattern of counting up by ones. And then we close our little fancy parentheses there. The other way to write it is called set notation, and it has a parentheses as well, and it says X Then you draw this bar, and then you write the same thing. And then dot, 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 parentheses. My parentheses are horrible. But these are just two ways to write it. This is called formal set notation. This means all the values of x such that 0, 1, 2, 3 are all in the set. And then this is just a way to write the domain. You might see it either way. You notice how they're very similar, so don't get confused if you see something like this. It looks similar to this for a reason. We're going to do the same thing for the range, except in this case we're talking about our y values. And we said that they had possible values of 0, 2, 4, and again we put these dots, which means that pattern that we've established here continues. Or in set notation, all the values of y such that 0, 2, 4 are contained. So when you turn the page, we have a different situation. We have a swimming pool, a volume of 7,500 gallons of water. It's being drained at a rate of 500 gallons per hour. So complete the table. So when 0 hours have passed, I still have the entire pool of 7,500. After 1 hour, if it's being drained at 500 per hour, I've lost 500. So I'm down to 7,000. At 2 hours, I'm down to 6,500. And then I've noticed that this is going up by 2, so I'm going to continue my table in 2s instead. This would be an 8. So go ahead and fill in the table following this pattern, and then do your graph, and then come back in with me. So I hope your graph looks something like my graph. And we're presented with this question again, should you connect the points, why or why not? We've had a similar situation. It was with the river, and we couldn't take out the water all at the same time. So we were able to even find the value that at 1 hour, it was at 7,000. So that's a point on the graph. I could take that even further and say that at half an hour, it would be at 7,250. So all the points between the points mean something. So in that case, I should connect them. Whew, that was bad. So yes, because all the points between the points have a meaning in the situation. Okay, so we're going to continue the same process with our independent-dependent variable. So our independent would be the hours, and the dependent would be the amount of water left. The next question, that's really bad handwriting, I'm sorry. The next question, what values for number of hours would make sense for this scenario? Well, anything bigger than 0, well, okay, so we need to go back to our graph for a second. So anything between 0 and, let's look back at our graph to see. So at 14, we still had 500 gallons left, so it would take 15 hours to reach 0. So anything between 0 and 15 would make sense. 12 would make sense, 12.5, 12.4, 12.2. So anything between 0 and 15 makes sense for the number of hours. And then a similar answer for the number of gallons, it could be any amount of gallons between 0 and 7,500. Because at some point, all of those numbers will be there, even 7,499, because 1 gallon will drain out of there. So the number of hours describes the x, and remember that's also called the domain. And then the number of gallons describes the y, and that's called the range. All right. So the vocabulary word associated with this set of information is called continuous. So a set of data is said to be continuous if the values belonging to the set can take on any value within a finite or infinite interval. So these are things that are measured. So we're measuring the time. So that's when we connect them, because every point has meaning. So be sure you write this down before you continue. Make sure you have all those blanks filled in. The word continuous kind of has the word continue in it because it all continues. So that's another way to kind of think about it. So in this case, the domain and range are written just slightly different. So I don't want to write down every single number between 0 and 15. 3.5, 8.25, every single decimal, every single fraction, like that's silly. So the domain and range is written as inequalities. So 0 is the smallest number it could be. So all of my x's are bigger than or equal to 0, but they're also less than or equal to 15. So all my x values are greater than or equal to 0, but they're less than or equal to 15. And then in that fancy set notation, you would say x values such that x is greater than or equal to 0 and less than or equal to 15. So again, we're not going to spend a lot of time on this set notation because they look so similar, you should be able to pick up on what that means. And then the range, our y values are greater than or equal to 0, but less than or equal to 7,500. And in set notation, any value of y such that they're greater than or equal to 0 and less than or equal to 7,500. So just make sure you have everything filled in. Go ahead and fill out your feedback form, and I'll see you tomorrow.